It does look like we've got some people trickling in. Patrick, why don't you go ahead and
Okay.
I'll start us off with a quick introduction, then I'll hand it off to you.
Sounds great. Thank you, Anna.
No problem. And hello, everyone, again. Thank you for being here tonight. My name is Anna Withers, and I'm the Farmer Outreach Coordinator with Springfield Community Gardens. And we're a nonprofit based in Springfield, Missouri, whose vision is a community where everyone has access to healthy local food. This workshop on harvesting crops and produce food safety is generously sponsored by the Community Food Projects, or CFP, grant from the USDA National Institute of Food and Agriculture. Our speaker tonight is the University of Missouri Extension Horticulture Field Specialist, Patrick Byers, and I will let him introduce himself further in a moment. But just some quick housekeeping before we get started. If you have any questions throughout the night, please ask as we go. You can click on the Q&A button at the bottom of your screen to type in a question, and we'll stop periodically to chat with Patrick about them. And then there's also a chat feature at the bottom of your screen. Please only use this for comments because that helps us keep track of questions throughout the night and make sure we're getting everything answered. Also, once you leave this workshop, a screen will pop up with a link to a post-workshop survey. And that survey is used in Springfield Community Gardens reporting to the USDA, and it also helps us provide meaningful workshops for you in the future. So we'd appreciate it if you could take just a few minutes to fill that out after the presentation. If you would like to refer to this workshop later, it will be posted on SCG's Agriculture Workshop playlist on YouTube. And I will put that link into the chat box as well as our website, social media, and tonight's exit survey, everything into the chat in just a moment. So I think that's it from me. Thank you all again for being here, and I'm going to hand it off to Patrick.
Thank you, Anna. Well, it's a pleasure to be with you here tonight. And as Anna mentioned, my name is Patrick Byers. I'm a horticulture field specialist with University of Missouri Extension. I'm based in Southwest Missouri. In addition to my primary job responsibilities, which are to help farmers with profitability and sustainability, I also have an appointment in produce food safety. And that brings us to the subject of our workshop this evening, which is harvesting crops and how that intersects with produce food safety. So let's go ahead and get started with the workshop this evening. Okay, Anna, can we see the presentation?
Looks good.
Okay. Well, when it comes down to produce food safety, of course, there are lots and lots of different factors that intersect into growing crops that are safe for people to enjoy and eat. And certainly lots of things happen in production during the time that the crop is in the field. Lots of things happen after the crop has been harvested and brought into a pack house or sent out to a market. But that intersection between the growing of the crop and the handling and marketing of the crop, that period of time that we call harvest, is a very critical point from the standpoint of produce food safety. And hence it deserves its own workshop this evening, which is exactly what we're going to do. We're going to delve into a number of different aspects of harvest and how we can take a look at harvest practices, and we can come up with plans to help make our crops safe. Now, if any of the folks on the workshop have been to the Produce Safety Alliance Food Safety Modernization Act Produce Safety Rule training, that's a mandatory training for farms that are subject to the Produce Safety Rule of 8 hours in length, very in-depth, very, very involved. You'll see some of the material from that training in tonight's training. But I've chosen to take a slightly different slant on the material and presenting it in the context of a very important aspect of crop production, which is harvest. So we'll be taking an in-depth look at harvest and produce food safety. As I mentioned, I'm a horticulture field specialist. I serve 9 counties in Southwest Missouri, and my primary job is to help farmers be profitable in the short term and sustainable in the long term. And a very important aspect of that, of course, is growing crops that are safe. And I have an appointment in produce food safety. I've worked in the produce food safety arena since 2009. And it's been my pleasure to work with a number of farmers on their farms, helping them to develop on-farm food safety plans. And tonight, our workshop, of course, is a sort of a general gathering. If anyone on the workshop would like to visit with me one-on-one, my contact information will be at the end of the presentation. I very much enjoy working with farmers on produce food safety, so feel free to reach out. We have a number of programs in place, including what's called an on-farm readiness review, where a team from Extension and the Missouri Department of Agriculture will visit your farm and go through all aspects of produce food safety on your farm. It's a chance to talk with people through the lens of produce food safety and get some advice, have a number of different eyes, take a look at what you're doing on the farm. As Anna mentioned, our workshop this evening is a partnership between University of Missouri Extension and Springfield Community Gardens. And Springfield Community Gardens' vision is a community where everyone has access to healthy local food. And it's my pleasure to team with Springfield Community Gardens in these workshops, both on produce food safety and on other topics of interest to farmers. And the third partner is the USDA. The USDA has generously supported our work with beginning farmers and farmers in general in Springfield through a number of grants through the USDA programs, such as the particular project that is supporting tonight's workshop. So for more information on these USDA programs, which are available to farmers of all scale, reach out to the Farm Service Agency, the FSA. FSA has offices in most Missouri counties. And typically within the FSA office, you'll find the staff of NRCS, Natural Resources Conservation Service, and the Risk Management Agency, or RMA. And both of these agencies have programs of interest to specialty crop farmers. All of this information is summarized on the farmers.gov resources website. Well, here's our outline of what I'd like to do in tonight's workshop. And as I mentioned, we'll have plenty of time for questions. We'll stop periodically, and if you have questions, please type them into the chat. We'll also have time at the end of the presentation to delve into any areas that you'd like to related to produce food safety. But my prepared material will first be a bit of introduction, and then we'll talk about some of the factors that farmers must consider as harvest approaches. And we'll focus in on water use and soil amendments, since they play a particular role in produce food safety. Then we'll talk a bit about animals and the pre-harvest crop inspection, how we can take a look at crops just before we harvest and ensure they're as safe as possible as we begin the harvest process. And then we'll finish up with some topics related to safe harvest practices. So from the standpoint of produce food safety, certainly the operations that we have in place as we grow crops in the field are very important. And certainly the operations that we have in place in our pack houses and also in the transportation channels that we have to move crop from our farm to a market are important. But really, very, very important is the intersection of those two parts of farming, and that's harvest. And harvest, of course, involves taking a crop from the field, moving it to a collection point, typically a pack house, where it is then handled and moved out from that point into markets. So tonight we're going to focus in on harvest and the things that we as farmers can do to ensure that our crops are as safe as possible. Now, the primary focus is going to be on microbial food safety, those contamination situations related to bacteria, viruses, and parasites. We'll touch a bit on other types of contamination that can occur as well. But our primary focus is going to be on microbial contamination. And as I mentioned earlier, you'll see a number of slides that are very similar to the slides that you may have seen in the Food Safety Modernization Act Produce Safety Alliance mandatory training, that 8-hour training that is so helpful. But we'll take a look at them through the lens of harvest. Now, the first thing we're going to talk about relative to harvest is water use. Now, obviously, water is a critical component of farming. We have to have water to grow crops. We also have to have water to manage crops after harvest. But the way that we use water, particularly where the water comes from and how we use water, can definitely impact produce food safety. So it's a good topic to start off with as far as the discussion of harvest. This picture is a picture of a pond, and this pond is used as a water source for a farm. And when we talk about water sources, of course, not all water sources are created equal. We'll see here in a moment that a surface water source, such as this pond, is different than a a subsurface water source such as a well, which of course is different than a municipal water source. So let's go ahead and talk a bit about water now at this point. So lots of factors impact the quality of water. And there's oftentimes many sources and uses of water on the farm. Sometimes the same farm may have several different sources of water. And then we have to recognize that water is definitely plays a role in produce food safety. It's very easy for human pathogens to be introduced into water, and then from that water to spread pathogens throughout areas in which we're growing and harvesting crop. So again, produce safety is impacted by all of these things. In our next few slides, we'll talk about how produce food safety is impacted by water. Now, there's 3 points of interest when we think about the risks associated with water. Okay, so these 3 points are, first of all, where does the water come from and what is its quality? Secondly, how are we applying water? And third, how are we timing those applications? So when we think about source and quality, is it public water? Is it groundwater? Or is it surface water? And how frequently are we testing? And do we understand how best to test water to get a clear picture of its quality? Application method, are we applying the water in such a way that it contacts the part of the crop that we're going to harvest? Or are we applying it in such a way that it doesn't contact the harvestable portion of the crop? Again, this is a very important aspect of managing risk associated with water. And then third, how close to harvest are we applying that water? You know, it's definitely a different situation if we're applying water at some point early in a production cycle compared to applying that water just before harvest. And we'll talk more about that here in a moment. From the standpoint of contamination, there are definitely differences in water sources. Typically, the safest water sources are public water supplies. In many cases, these water supplies have been treated, and in all cases, these water supplies are routinely tested by the authority that delivers the water, by the city, the town, the county, or whatever it might be. In the middle is groundwater. Frequently, groundwater is safe. Frequently, groundwater in the way that it is present is safe. But of course, we don't know that because groundwater can become contaminated. We don't know that without testing. Surface water. Surface water is open to the environment. It includes streams, ponds, lakes. It includes water collected off of surfaces such as roofs. Any water that is open to the environment is considered to be surface water. And surface water is almost uniformly carrying some load of contamination. The amount, well, again, we don't know without testing the water. But we can look at this continuum from public water supplies through groundwater to surface water and get a clear picture of the increased risk as we move towards surface water. Now, talking about methods of irrigation. So there are different ways that we can apply water to crops, especially close to harvest. Overhead irrigation. This is where we use a sprinkler system to spray water over the top of the crop. This is a direct water application method, and almost inevitably, this allows water to contact the part of the crop that we're then going to harvest. Flood, which is surface or furrow irrigation, is less risky. The water typically doesn't contact the harvestable part of the crop with many crops. Now, granted, crops like greens, like strawberries, like root vegetables, yes, that water is likely to contact the crop. But with crops where the part that we plan to harvest is some distance from the soil, this is a type of irrigation that's much less likely to contact the actual part that we harvest. Now, keep in mind, of course, there can be movement of water through splashing, through people walking in these channels and splashing it up during harvest. So it's not entirely without risk. The safest form of irrigation with many types of crops relative to getting the harvested part of the crop wet is drip or trickle. Now, with this approach, of course, the water is applied directly to the soil. Unless there's a problem, the water does not contact the above ground parts of the plant. So again, a very safe approach with crops like tomatoes, bell peppers, trellised crops like cucumbers, or berries or tree crops. It's not completely without risk, though, because there can be breaks in the line. Water can spurt up and wet crops. And of course, crops such as root vegetables and oftentimes greens are wetted, even using drip or trickle irrigation systems. But in general, the safest form of irrigation relative to produce food safety is drip. Less risky, or a type that carries a bit more risk would be flood. And the riskiest type, of course, is overhead or sprinkler irrigation. Again, a good thing to think about from the standpoint of managing risk is less contact with water equals lower risk. So when you're thinking about risk and you're thinking about water, are you applying the water using a direct water application method? And if you can truthfully say never, then the risk from water is very low. If the answer is yes, then you've got to be thinking about risk. And you're going to be looking at the type of commodity, the quality of water, and how close to harvest you're using that water. Again, with direct water applications, even if you start with clean water, there still is a risk associated with wetting the harvested part of the crop. Now, we know from research that pathogens on produce may die off over time. So, for example, there may be a situation where early in a cropping cycle, contamination is a crop becomes contaminated, perhaps through overhead sprinklers. But if there's a long enough period of time from when that happened to when the crop is harvested, we can expect some level of that contamination to die off. Now, how much? It's a little bit challenging to say because the die-off rate is influenced, first of all, by desiccation, the drying out of the crop, the presence of sunlight, particularly the UV irradiation component of sunlight, temperature and humidity. The warmer temperatures and drier humidities can lead to increased die-off rates compared to lower temperatures or higher humidity. And then starvation and competition can also lead to the die-off of pathogens. Now, keep in mind that pathogens can be protected on the plant and survive for extended periods of time. When we think about a crop like head lettuce, if contamination occurs within the leaves of the head, they're protected and they're less likely to die off over time. If we think about a crop such as a strawberry, looking at a strawberry fruit, it's fascinating to see what a strawberry fruit looks like under magnification. There's all kinds of indentations and crevices where pathogens such as bacteria can lodge and then survive. And we know too from research that under some conditions, pathogens can even regrow on a plant. So the bottom line is it's best to avoid contamination. Yes, we do know that pathogens may die off over time, but by far the best risk management strategy is to avoid contamination from the offset. And particularly as we move into harvest, let's keep this in mind as our mantra, avoid contamination. Now, the produce safety rule requires farmers once a year to inspect their agriculture water sources and their water distribution systems. So, for example, we can have contamination at the source of water. For example, if we're drawing water from a pond or a lake, or we can have problems somewhere along the line from the water source to where the water is delivered to the crop, somewhere in the distribution system. So, for example, if we're using municipal water, yes, it may arrive on the farm clean, potable condition, free of contamination. But as we move that water through our distribution system, if there's a break or some other point where contamination can enter into the system, the water that we distribute to the crop can be contaminated. So it's very important, at least once a year, to examine water distribution systems. Again, and this is a requirement of the produce safety rule. And it's also, of course, a very important management strategy to keep water sources free of debris, trash, domesticated animals, and other hazards. And this is especially the case with surface water. As an example, if you have a pond that you're using as an irrigation source, it's a good practice to exclude domesticated animals from that pond. So fence the animals out to keep the pond in a less contaminated condition. Anytime you allow animals access to a pond, they're going to defecate in the vicinity of the pond, sometimes actually in the pond, and this can lead to an increased load of contamination in that pond water. Now, the only way that we can truly understand the quality of the water that we're using, especially as we move into harvest, is through water testing, is through establishing what's called a microbial water quality profile. And again, as I said before, the only way to understand this is to test the water. Now, if we understand the quality of our water, the water quality profile can certainly give us a feel for long-term quality of source water. If we know from experience testing a well, for example, that it consistently tests clean, that's a pretty good thing to know from the standpoint of using that water close to harvest. Again, the better the water quality close to harvest, the less the risk of contamination at this point. That also can help us to understand appropriate uses for each source. For example, we can allow some level of contamination in water that's used to produce crops in the field. But once we move into harvest and post-harvest, any water use has to be potable. That water quality must be potable or free from contamination. And another thing the water quality profile can help us with to understand if we need to take corrective measures, if we need to do something to reduce or eliminate contamination in that water. So again, testing is a really, really good idea for farmers to understand the microbial quality of their water. Now, the established indicator of water quality through the Food Safety Modernization Act Produce Safety Rule is generic E. coli. Now, what is generic E. coli? Well, E. coli is a bacteria that is found in the guts of warm-blooded animals, sometimes also found in the guts of cold-blooded animals. But in many cases, contamination issues related to E. coli is traced back to contamination from the feces from warm-blooded animals. And so E. coli is frequently found in the digestive tracts of warm-blooded animals. And not all E. coli, of course, is pathogenic. We all have strains of E. coli in our intestines that are harmless, but there are strains, of course, that are pathogenic that can cause foodborne illness. And so a good way to understand whether or not contamination present is to look at E. coli. Now, looking at this diagram here, frequently water test reports come back with a measurement of what's called total coliforms, a count of total coliforms in the water sample. Now, total coliforms is a broad, general type of a test. Coliforms frequently are related to contamination with feces, but not all coliforms are going to make you ill, okay? So the Food Safety Modernization Act, when it was written, it was decided to use a more specific indicator. And so moving within total coliforms, we come to fecal coliforms. These are the coliforms that definitely come from fecal sources. And within fecal coliforms, there is a smaller subset of generic E. coli. And generic E. coli frequently are found in feces. And so if we find generic E. coli in a water test, there's a pretty good chance that the contamination has occurred because of the presence of feces in that water. Now, we could be even more specific and look at pathogenic E. coli, those E. coli strains that actually make people sick. The problem with this is that it's a very expensive test to do, and it's very specific. And it was felt by those people who were experts in this area that looking at generic E. coli actually gave a better picture of contamination, and of course, using lab techniques that are affordable. So the generic E. coli indicator is the indicator that's frequently used to measure water quality. And it's the indicator used in the Food Safety Modernization Act Produce Safety Rule. Now, the water quality criteria used in water up to harvest does allow some level of contamination. And there are a couple of indices that are used. The first one is what's called the geometric mean, which can be loosely thought of as the average level of contamination in the water. And the geometric mean that is allowed is 126 or less colony-forming units of generic E. coli per 100 mLs of water in the test. There's a second index, which is the statistical threshold value. You can think of this as a high value. Now, granted, when we calculate geometric mean, we take into account high levels and low levels to arrive at the geometric mean, but it's still important to understand what those high levels are. And the statistical threshold value allows us to do that. And the highest statistical threshold value allowed in the produce safety rule is 410 colony-forming units of generic E. coli per 100 mLs of water. Now, in a moment, we'll see a video looking at water testing procedures. And you'll be hearing the technicians talk about this colony-forming units per 100 mLs of water as the standard way that we look at contamination in water. So we'll be seeing this in detail here in a moment. But again, to start off the discussion, your water level, your water quality amounts, the geometric mean levels are 126, and the statistical threshold value is 410. And if anyone has any questions about what all of these mean, please reach out and I can share with you some calculators to help you develop these numbers based on the results of your water tests. Okay, now, as far as water testing, there are some general requirements in the produce safety rule relative to the source of the water. So if you're using public water, water that is delivered to your farm in a potable state, you're not required to test that water. You are required to obtain a copy of the test results or current certificates of compliance from whoever supplies that water. And these agencies, these municipalities, counties, whatever they might be, are very happy to provide these test results or these certificates. All you have to do is request them. Now, is it an idea? Is it a good idea to test potable water when it arrives on your farm? My advice is to periodically test water at the point of delivery to the crop. Because as we said before, if there's any problems with your distribution system, it may be hard to understand that there is a problem. But if you test that water at the point where it's delivered to the crop, in the drip irrigation line or someplace like that, and the water test comes back with contamination, then there's some problem between the point where the water arrives on your farm and the point where you're using that water. And it's in your interest to figure out where that problem is. What about groundwater? Well, initially, the produce safety rule requires farmers to test their water 4 or more times during the growing season over the period of a year. And then these 4 levels are then used to develop the statistical threshold and the geometric mean. After that, in following years, the farmer is required to collect 1 or more samples each year after that initial year. And again, to get a feel for what's going on as far as the water quality in a well. Now, if the well comes back with any load of contamination, then obviously it's in your interest to figure out what's going on. Because wells by their nature should be delivering potable water, water that does not carry any load of contamination. Now, what about surface water? So surface water is almost invariably contaminated. It carries some load of contamination, and the produce safety rule recognizes this by requiring more tests. Initially, farmers are asked to test their water 20 or more times over a period of 2 to 4 years. And then once they've gone through this initial period, every year thereafter, they are required to test the water 5 or more times. And these 5 or more samples then roll into the calculations of the statistical threshold and the geometric mean. Now, as far as assessing water quality, as I mentioned, water testing is really the only way to get a clear picture of water quality. So it's a good idea to sample your water sources regularly and frequently. And it's also a good idea to follow good agricultural practices to protect and maintain water quality. Some of those things we talked about with surface water, such as fencing animals out, establishing grassy buffers around ponds and streams, and keeping organic matter as much as possible out of the pond or the stream are helpful in maintaining water quality. So again, just making assumptions is not helpful. You have to have an active program in place to maintain water, to understand and maintain water quality. Where do you collect samples? Well, if it's surface water or groundwater, you want to take a representative sample that's appropriate for the water source. So what is a representative sample? Well, in the case of surface water, if you're using a pond or a stream, collect that water close to the point where you're taking it into the pump that's pressurizing the water. So for example, if you have an intake pipe well out into the pond, then try to collect your water sample close to that point. You may have to get wet or go out in a boat to get close to that point, but that's the point at which to collect your water sample. If you're collecting a sample from groundwater, try to collect that sample as close as possible to the well source. Municipal public water supplies, again, you're not required to sample this water. You're not required to test this water. But as I said before, it's a good idea to sample periodically at different points in the distribution system to understand if there's any problems in your water distribution system, at some point from where the water arrives on your farm to the point where you're using that water. Now, be sure that you follow the sample submission instructions from the laboratory. Typically, the laboratory will provide you with a sterile bottle, and it must be a sterile bottle. Otherwise, at the beginning of the testing, otherwise contamination can occur and you won't get an accurate test report back. Don't rinse the bottle before you sample. And again, if you're testing in a distribution system, let the water run for a while before sampling. Thus, you get a representative sample of the actual water quality. So for example, if you're collecting from a well and you have a hydrant close to the well, turn the hydrant on, run it for a period of time, and then collect the water sample. Now, in my experience, the lab that you're using will provide instructions on how to collect the sample. And there'll be instructions, for example, on how long to let the water run before actually collecting the sample. In Missouri, the public health departments in each county can provide sampling kits and instructions in how to collect water samples. And right now we're in 2022. And for the next 2 years, we have a program in place to allow for free water tests for produce farmers. So for more information on this free water testing program, please reach out and I'll be happy to provide that to you. Where do you go for testing? Well, you want to make sure that the lab that you choose can provide the tests that you need. And there are a list of tests that are accepted by the FDA. And again, at this point, we're now 5 years into the produce safety rule. And many labs now understand what is needed to provide a water test report that is in compliance with the FDA. So again, make sure that you choose a lab that can do that. Now, we'll see a video here of a lab that performs water tests that are approved by the FDA. And so, that's what we'll be focusing on in this particular video, but that's not the only test that is accepted by the FDA. There may be other tests that labs conduct that will be equally acceptable to the FDA from the standpoint of the produce safety rule. So let's watch a video. Now, again, this is a video that I developed from a visit to a university water testing lab. This was actually at Kansas State University at their lab in Olathe. And we're going to go through all the steps. I find it fascinating. I received lots of questions about what really happens in a water testing lab. So this effort is a chance to understand what goes on when you submit that water sample and then the report comes back, what happens in between. So let's take a quick look at water testing and the lab. Okay, Anna, can we see a dark screen?
Yes, we can.
Okay.
Hi, everyone. My name is Londa Nwadike, and I'm a State Extension Food Safety Specialist for both Kansas State University as well as the University of Missouri Extension. So today we're here at a water testing laboratory here at Kansas State University Olathe, and I just wanted to talk to you a little bit about why water testing is important. As a produce grower, it's really important that you know the quality of your water that you're using for irrigation, for mixing with chemicals, for washing your hands, for if you are doing any washing of your produce. It's just important that you know the quality of your water so that you can use it safely and you can produce as safe of a product as possible. So our laboratory here in Olathe, we also have a laboratory in Manhattan that does the same testing. And on the Missouri side, we work with the Missouri Department of Health labs, and they do the same water testing that we do. Our labs can only do microbial water testing, so we only look for generic E. coli and coliforms in the water. But if you are a produce grower and are interested in testing for heavy metals or for pH, there is labs in Columbia and Manhattan that can help you with that.
Hello everyone, my name is Manrit Puller and I am a research assistant professor in the Department of Horticulture and Natural Resources and the Food Science Institute at Kansas State University. My job focuses on produce safety research, which highly emphasizes on agricultural water quality, and today I'll be talking about what we do with water testing in our lab and how do we analyze these samples.
Hi, my name is Olivia Haley, and I'm a PhD student in the lab of Dr. Buller. So I work with agricultural water quality and produce safety, in particular looking at interventions such as ultraviolet light technology. And I help with the analysis of any water samples that come from the producers.
Hi, my name is Yeqi Zhao. I'm a master's student in Kansas State University, and I work in Dr. Buller's lab. And my project is really on the agriculture water testing and agriculture surveys. And I'm also like helping with the water testing analysis.
So growers submit their samples to our lab. We receive them in a box, something like this, which comes with the ice pack. We receive the samples along with a submission form that has the details of the water sample, and then those samples are processed using reagents and this machine that has a set of reagents. They are sealed in here, then they are put back into the incubator. This is how a sealed sample look like. This is placed inside the incubator up here for 24 hours at 35 degrees C. If the water is clean, it comes out to be like this, colorless water cubes. If it is highly contaminated, it comes like this with yellow cubes. And based upon the formation of color, some of the wells, they fluoresce and some of them they're not. So based upon that, we calculate the number of total coliforms and the number of generic E. coli. And these numbers are reported on your submission forms that you get back from our labs.
Once we receive our sample, we bring it to the processing area. So the sample should be received in a foam cooler or any other sort of cooler that's able to keep its temperature, and also with ice packs, just to keep the sample at appropriate temperature for transportation. So then we take our sample to the sample processing area. And the sample usually also comes with a submission form, which has the information of the grower and where the sample came from, and then also the sample's name. So then we match the sample to the sample form, make sure we have enough samples and that they're the right samples. Okay. So this test is designed for 100 milliliters of water. So you want to make sure that it's close to the 100 milliliters fill line. If it's too low, then you'll definitely want to contact the grower because the test is designed for 100 milliliters. And if it's too high, you can always aliquot to the, or dispose of the extra liquid to the 100 milliliter fill line. Okay, so now that we have our sample, we're just gonna turn on the Quantitre sealer. There we go. So the sealer is basically sort of like a hot press. It uses high temperatures to seal our Quantitre, which is what we're going to pour our water into when it's ready, once we add our reagent. To prepare your sample, you're just going to unscrew the cap and then snap off one of the Call Alert snap packs, the entire thing, into one sample. Okay. And then you'll put the cap back on and shake it. So the important thing is that the Call Alert reagent is completely dissolved. So you want to just shake it until it's dissolved. Okay, so now the bottle might, the reagent and the shaking might produce a foam on the surface. So you just want to let the bottle sit for about 5 minutes until the foam calms down. Okay, so after 5 minutes, the foam might not have completely subsided, but you just want the majority of the foam to be gone so that you can fill up all of the wells. So now we're ready to fill our Quantitre. You'll just open the sample. And then to open the actual tray, you just want to push or grab the tray in your hand, push the back of the tray, and then you'll want to grab the tab that's on the top. And so the important part is not to touch anywhere that the sample is going to go into or that the sample is going to touch. Okay. And then you'll just pour the entire sample in. Okay. And then we're just going to put the tray into the mold upside down. So the tray will go into the sealer and should press up against the tray with the indentation side upward. Okay. So you'll just make sure that it's completely in the mold. And then you'll push it through the Quantatray sealer. Okay. And so the sealer would have heat sealed the back. And when you flip it over, you should have liquid in each of the wells. So now we're going to take our sealed Quantatray containing our sample, and we're just going to incubate it for 24 hours at 35 degrees Celsius.
So now, after 24 hours, we open the incubator and get the quantity tray out. So you can see there's a yellow color forms in these wells. This means like they have color form in it, and we need to test the generic E. coli. We need to put this quantity tray under the UV light, like here. And then we turn on the light. We can see the fluorescence under this light. So that means the generic E. coli is in there. And like normally you will mark the fluorescence cubes with the like lines to represent that cube has the generated E. coli. And then there's large walls and small walls. We will count the number of the fluorescence of the large wall and the small wall. And then we will record this number to here. So this template means like the yellow one, which is the color form, and the yellow plus the fluorescent, it means the generated E. coli. And after we know the number of the fluorescences, we will have this cheating sheet, the table. Here we got the small walls positive, and here this number is the large wall positive. And we will like see like if we have 11 number 11 of the small walls positive, which is 11 of the small walls that contains fluorescences, and then we have 11 of the large one that also contain fluorescences. Then it goes down here. The number of this is 24.8. So that means like the result is 24.8. And then we got the result here, and we fill up the submission form. So the testing result says we will write down the 12 point. We will write down 24.8 CFU per
microliter. No, it's MPN. Yeah, it should be MPN per microliter. And then after we fill out the submission form, we need to send back this submission form to the growers or the person who give the sample to us, and they will have the send result via we can send back from email, phone, or mails. It all depends on whether they want.
So when you get your lab results back from our laboratory, either in Manhattan or Olathe, they'll be on a form something like this. If you get the lab results back from a private lab or from the Missouri Department of Health, they might be in a little bit different format, but the lab results will tell you what your generic E. coli is per 100 ml sample, and it might also tell you what your coliforms are. So on the generic E. coli per 100 ml sample, it might say less than 1, or it might say 0. And just a note too that CFU, coliform forming unit, is basically an equivalent term to MPN. So you might see one of those two acronyms on there. So for post-harvest water, for water that we're considering to be potable, you want that level to be 0 or less than 1. If you're using the water before harvest, then generally speaking, we'd want the level to be below 126 CFU per mil. And again, that's for the generic E. coli. So you'd like your generic E. coli to be less than 126 in general. The lower, the better. But if you do have questions about your results, that's something that Kansas State University Extension and University of Missouri Extension can help you with. We can help you with better understanding the results, and we can also help you with what to do if you do have high samples. So if it comes back seeing that your water coliform levels, your E. coli level in your water is really high, we can help you with identifying why it's so high and hopefully helping you to reduce that level as well. So we do this work, including water testing, to help support local produce growers in Kansas and Missouri. And this is important because it's helping economic development in Kansas and Missouri, but it's also helping provide more fresh fruits and vegetables, more local fresh fruits and vegetables to consumers in Kansas and Missouri and beyond as well. And it's so important for people to eat more fruits and vegetables and to help economic development. So that's really why we want to help support our local produce growers to produce safe products as much as we can through providing water testing and other produce safety services.
Okay, let's go ahead and return to the presentation. Do we have any questions at this point, Anna?
None at this time.
Okay. Again, please feel free to add any questions you might have into the Q&A box at the bottom of your screen. And hopefully you enjoyed that video. I've often wondered what really happens in a water testing lab. And so when I had a chance to shoot this video, it answered a lot of questions for me and hopefully provided some information for those of us on the meeting tonight. Now, there are some corrective measures that you might consider if your water tests come back with high levels as we get close to harvest. And the first thing is to do what's called applying a time interval for microbes to die off. And this, again, is typically the time between the last application of water and harvest. Now, how would you know that you would need to be thinking about something like this? Well, let's say, for example, you were growing tomatoes, and these tomatoes were trellised, they were all well off the ground, and you had in place a trickle irrigation system that was under a plastic mulch. There was very little risk that that water would actually contact the part of the crop that you're going to harvest, those tomatoes that are ready to harvest. Let's say there was a problem and somehow a hole was created in the plastic and the irrigation line was damaged and water spurted up and got the tomato fruit wet. Well, If you don't have a water quality profile in place and you don't understand what's going on with the water as far as possible contamination, at this point, you really need to be testing that water before you harvest the fruit. So collect that test as soon as you can. Typically, the turnaround time for a water test is quite short. You should have the results back soon. And then once the results come back, if the water tests potable and clean, great, you can proceed with harvest. If they come back indicating contamination of that water, then you're allowed to apply a time interval. Now, you're allowed to apply 4 days, and over these 4 days of time, there is an assumption made that a certain percentage of contaminants, these biological contaminants like bacteria, will die off. And if your level is at or below the starting point, where after 4 days the level is low below the threshold, then everything is fine. The crop can be harvested and you can proceed. But again, without that water test, you really don't know what the quality of the water is at the point where you accidentally got your crop wet. Other things that can be done, of course, reinspect the water system and make corrections. And third, treat the water if necessary. Typically, this is not a practical approach in the field setting just before harvest, but it is still an option that is allowed. So again, water application and timing. Keep it, and this is what I was talking about as far as that die-off of organisms. And again, for more information on this, please reach out, and we can provide you with guidance as far as how to calculate 0.5 log die-off and what a reasonable amount of contamination at starting point will result in less than threshold values after 4 days. And quite frankly, the water can have a fairly significant load of contamination. And after 4 days of die-off, you can have levels that are at or below the threshold. But again, without knowing what your starting point is, you really can't apply this with any accuracy. Now, some other things, again, I mentioned broken emitters, water application, then that's the procedure you should take that I just mentioned. Sometimes we have human mistakes where we might use the wrong water to mix up a spray that's applied at harvest, or maybe we forget to turn off the irrigation pump when we get a flood in the field. Well, again, in those cases, we want to evaluate whether or not the water has contacted the produce. And if it has, then we need to test the water to understand its quality. Now, an entirely different situation is a flood event. And this is a situation where flooded water comes in from outside the field, typically from an overflowing stream or an open body of water, and then it contacts the crop, the harvested part of the crop. The FDA has ruled that water that has been contaminated by flood water, the produce that has been contaminated by flood water is to be considered adulterated and cannot be used for human food. So if we look at this picture here, this is an example of a situation where a stream rose and flooded a crop of tomatoes, and the fruit was contaminated by flood water. In this case, the entire field was lost because of the very high potential for contamination. Now, this is not the same thing as a flood that results from a heavy rainfall where the water pools in a planting. In that situation, it's not part of a natural disaster. It's not part of a flood from an open body of water. And in some cases, produce in this situation can be used, in other cases not. For more guidance on that, please reach out if you're in a situation where you have to make a determination. Now, if your test report comes back higher than you expected and we're close to harvest, then figure out what's going on. Again, with the surface water source, perhaps manure has gotten into the water. Perhaps there's fecal contamination from a flock of geese that landed on the pond. Maybe there's some situation in the supply and distribution system that's causing problems. Maybe there's a problem with the wellhead. But as soon as you realize there's a problem, implement practices to take care of the issue. And just to give you a couple of examples. So if you're using a surface water source, for example, and you're using an overhead sprinkler where it's inevitable that the crop is going to get wet, the harvested part of the crop that's going to get wet, and you're applying this water close to harvest, this is a very risky situation because, again, surface water applied with an overhead sprinkler is going to contact the harvested part of the crop with contaminated water. Another situation, we're using surface water, but we're using drip irrigation. Again, using an approach where the water does not contact the harvested part of the crop. This can be used near harvest with a much lower level of risk. Not completely without risk, because sometimes accidents happen, but a much less risky scenario than the first example. Okay, do we have any questions on water before we move on to soil amendments?
No, I think you can go right ahead.
Okay, now we're going to turn our attention to the use of a soil amendments close to harvest and how that might impact produce food safety at harvest. So first of all, what is a soil amendment? Well, it's something that we add to the soil to improve and support plant growth and development. Sometimes there's other benefits associated with amendments. They may reduce erosion and sediment runoff. There's lots of different types of soil amendments. Some amendments can present produce safety risks. And it's important as farmers that we understand these risks and we put into place good agricultural practices to reduce these risks, especially as we approach harvest. So what about biological soil amendments? Those amendments that come from a biological source? Well, they include things such as untreated manure. And these biological amendments carry a significant microbial risk. Manure is almost universally contaminated with organisms that can make people sick. Now, synthetic chemical soil amendments like fertilizers can also impact food safety if they're not used properly. And whenever you use an amendment, you should assess the risk. And you should think about what the amendment is, and you should think about how you're using it. And you should particularly be thinking about how close it is to harvest. So again, assessing risks, what type of amendments are you using? If it's raw manure, it carries a significant amount of risk. If it's been properly composted, a much lower level of risk. Which crops are receiving the soil amendments? Is it fresh produce that you're going to be harvesting and using, or is it an agronomic crop? Obviously, fresh produce carries a higher level of risk. When do you apply it? Is it applied close to harvest? Well, there's likely a higher level of risk at that point. How do you apply it? Is it incorporated or injected, or is it applied on the surface? If it's surface applied, then the likelihood of the contamination in that amendment spreading to the plant and the harvested part of the plant is higher than if it's incorporated into the soil. And then how much do you use and how often do you apply it? Now, again, chemical soil amendments, again, very little risk from the standpoint of carrying human pathogens. Commercially prepared fertilizers very seldom carry human pathogens. But of course, there can be other risks associated with using chemical soil amendments. So we have to be cautious with these as well. They may not carry biological risks, but they can carry other risks as well. So they should be used properly, and all application instructions should be followed from the standpoint of their use. What about vegetative waste? What about things coming from plants that, at least in theory, shouldn't carry any load of contamination from fecal sources or from some other animal source? Well, they're not completely zero risk. They can carry some risk, but again, typically a much lower level of risk if the waste is coming from vegetative sources versus animal sources. So again, waste such as produce food preparation waste, the outer leaves of lettuce, for example, that are removed during minimal processing, perhaps vegetables that are out of date from the grocery store, or perhaps food products that have been removed from their packaging. In many cases, these carry a much lower level of contamination than waste coming from animal sources. What about those amendments that are not manure-based? We use things such as bone meal, blood meal, feather meal, fish emulsion as fertilizer sources, especially in organic or sustainable production practices. Well, these do carry some level of risk, but in many cases, these amendments have been processed. They've been exposed to heat sources or steam or some other processing that reduces the level of organisms, biological contamination that might be present on them. If they are not processed, then they have to be considered as untreated soil amendments of animal origin, and they should be assumed to be contaminated. But again, as I mentioned, in most cases, these are treated somehow to make them much safer to use. Okay, so now let's turn our attention to untreated soil amendments. And here we're typically talking about manure. And most of us understand what we're talking about when we say raw manure, but there are some other types of manure that carry equal levels of risk. So raw manure, aged or stacked manure, untreated manure slurries, untreated manure teas, agricultural teas with supplemental microbial nutrients, and any soil amendment that's mixed with raw manure. So, stable bedding mixed with raw manure carries a significant level of risk, perhaps at the same level as raw manure itself. So again, all of these should be considered to be untreated soil amendments that carry a high risk. What about treated soil amendments? Well, if the treatment is such that it reduces or eliminates the microbial load in the soil amendment, then these can be used much closer to harvest and can be used in a much safer fashion. A typical process that would treat soil amendments is composting. Okay, now with composting, temperature is the primary way that we reduce pathogens. Okay, there's other things going on in composting that contribute to the death of pathogens as well. But it's important that the composting process take place in such a way that it's been scientifically validated to reduce pathogens. Now, not all composting processes are equally effective at reducing pathogens. For example, if you just pile up manure and organic matter and just let it sit, frequently there are parts of the pile that don't heat up sufficiently to reduce biological contamination. On the other hand, a properly validated process where the pile is turned regularly and temperature is recorded to make sure that all parts of the pile are exposed to these critical temperatures may produce compost that is considered to be microbially safe. It's all in the process. Now, what about application? What about the way we use these amendments? Well, from the standpoint of these amendments, if we have amendments that contain manure, let's apply them to crops that we don't eat fresh. Perhaps we can figure out ways to maximize the time between the application and harvest. Let's figure out a way to apply it so that the amendment doesn't contact the harvestable portion of the crop. It's not a good idea to side dress crops with raw manure. And we want to make sure that things that we do in fields adjacent to produce crops don't cause a problem. For example, manure can be spread on the wind during application and move into produce fields. It can also move on water after rainfall or runoff. So we want to be cautious about what we're doing in adjacent fields or fields that are adjacent to produce crop fields. Now let's talk a little bit about those application intervals. How close to harvest can we safely use manure? Well, the Food Safety Modernization Act Produce Safety Rule does not talk about a specific interval. And this is partly because we really don't know with a great deal of certainty how long some of these pathogens will survive in the soil after a manure application. We do know that they can survive for some period of time, but we really don't know what that period of time is. There's a lot of research underway at present to answer that question, but until that question is answered, the recommendation is to follow the National Organic Program Standards. Those are called the NOP standards. And those standards are 90 days from the application of manure or another untreated soil amendment to harvest. And this is for low-risk crops. This is for crops where it is unlikely that the manure could directly contact the harvested part of the crop. And 120 days from application to harvest for high-risk crops. What would be a high-risk crop? Well, this picture shows an example. Lettuce, other types of greens that are grown close to the soil, strawberries, herbs, root vegetables, melons. These are all examples of crops where the harvested part of the crop is close to the soil and where the likelihood of contamination from an untreated soil amendment application is higher. Now, again, raw manure must not be applied directly to the harvestable portion of the crop. Treated soil amendments, those amendments that we know are safe, can be applied up to the day of harvest. There's a 0-day application interval, for example, for compost that has been treated by a scientifically validated process. So again, this is a very important thing to understand. Do we have any questions on this at this point, Anna?
So far, we are good. You can continue.
Okay. Now, some more thoughts as far as handling recommendations. It's a good practice to have tools and equipment that are specific for handling soil amendments. It's so easy to take a tool that we've used in applying manure or something like that, and then turn around and use that tool during harvest. And this can be a serious issue. These tools have to be thoroughly cleaned and sanitized, and it's much safer to have dedicated tools for specific jobs. Try to direct traffic, particularly traffic into harvest fields, around and away from soil amendment storage or processing areas. This will reduce the risk of cross-contamination on your shoes, perhaps on your clothing or on your hands from soil amendment storage areas into harvest areas. It's important that anyone who handles soil amendments should understand their proper use. And again, some of these things to think about to make sure that workers understand that tasks that require managing raw manure or compost should be completed before tasks that involve harvest. Make sure that clothes, boots, and gloves are clean before handling produce. Again, if you're working with soil amendments, especially manure, or you're working with animals, you'll need to decontaminate before you begin to harvest or work with produce. And it's critically important to wash hands after handling manure or other untreated soil amendments. Wash hands before handling produce. If you're using soil amendments, particularly manures, you want to keep records. You want to remember when you applied these so that you can apply those 90 or 120-day intervals with confidence. It's so easy to forget specifics when it comes to things like application dates and rates. So write these down. Write these down. If you're doing on-farm composting, you should be keeping records that demonstrate that your composting process has adequately treated that pile of compost. If you can't demonstrate that you've used a scientifically validated process, then it's best to treat that compost as if it is microbially contaminated. So again, back to on-farm composting, you'll be recording time, temperatures, the number of turnings, and other processing steps such as placing insulating blankets over the compost pile to hold in the heat. So again, if you're using on-farm composting and you want to use that compost as you would an amendment that is microbially safe, you have to be able to demonstrate that it's been through a process that is scientifically validated. For more information on that, please reach out and I can share information on that with you. Now, if you're buying soil amendments from a third party, it's a good practice to request from that party the documentation that their compost or their amendment has been through a scientifically validated treatment process. And reputable compost suppliers keep this documentation on hand, and they're happy to share that with you if you request it. Okay, so corrective actions. What do you do if there's been a problem? What do you do if there's been a soil amendment that might pose a microbial risk to the crop? Or what if we use an amendment that, well, perhaps we thought was properly treated, but now we discover is not properly treated? Or what happens if an amendment accidentally contacts the harvestable portion of the crop? Well, you want to think about alternative market options first. If this is a crop that you were planning to sell as a fresh product that would be consumed raw, then you will need to think about an alternative market option. Perhaps there's a processing market. Perhaps there's some way that you can use that crop in a process that involves a kill step to eliminate any contamination that might occur. Okay, do we have any questions now at this point, Anna, about soil amendments, especially untreated soil amendments of biological origin?
Nope, not at this time.
Okay, now let's talk about a very important aspect of harvest, and that's the pre-harvest crop inspection. Looking at this picture, this is an example of a pepper close to harvest. These are miniature peppers, and this particular pepper was chewed on by a mouse. And the likelihood that this mouse left some contamination behind is really high. And so this pepper would not be a pepper that you would harvest, put into the pack, and then sell. So pre-harvest crop inspection allows you to intercept portions of the crop that with reasonable, in the eyes of a reasonable person might be contaminated. So let's talk about what a pre-harvest crop inspection involves. And this is largely tied to animals and the presence of animals in the field close to harvest. So again, animals are a produce safety concern because they carry human pathogens and they can spread human pathogens, certainly by depositing feces or poop in fields, and they can also spread this poop around as they move. We also have to recognize that animals can be difficult to control. The mice that caused the problem with that pepper were in a high tunnel, and the farmer had no idea that the mice were there until he did a pre-harvest inspection and noticed their damage. Even if we use fencing or exclusion practices, it can be very difficult to keep animals out of produce fields as we get close to harvest. And this diagram just shows that there are lots of ways that animals can interface with produce as we approach harvest, causing problems. They can move into a field. There can be domestic animals or wild animals that can move into a field. They can also contaminate water sources. Just lots of ways that managing food safety on a farm can be a bit complex. Now, again, animals are naturally present on the farm. And in many cases, we can't control these animals with lethal methods. We can't destroy them because they're protected by county, state, or federal law. Sometimes these animals are resident, they're present year round. Other cases, they're transient. They may be flying in or migrating in. And we have to recognize that there are many cases where wildlife is in close association with human activities. For example, seagulls feeding at dumps or starlings at cattle feedlots. And the risk of these types of wildlife carrying contamination is typically higher because they've been associated with the areas where contamination is likely. Okay, now as we get close to harvest, how can we assess risk? So some things to think about. Do you find wildlife feces? Do you find poop in your produce fields? If you do, how often? Is it widely distributed? And has it contacted your produce? Now that upper picture with the alligator, that's not very likely in Missouri. But there are a number of different types of animals that frequently can enter produce fields. Things such as deer, things such as migratory birds, things such as resident birds, raccoons, possums, coyotes. The list goes on and on. And is our farm in an area where there's large numbers of animals? Again, in Missouri, particularly in southern Missouri, we have a high population of deer. It's not unusual to have 20 or more deer per square mile in Missouri. So the likelihood of deer entering produce fields is high. And what management practices can we do to limit wildlife contamination of produce fields and water sources? So let's talk a bit about this. Now, we should be monitoring wildlife activity. We're definitely keeping our eyes open as we're working with crops. We're looking for feces. We're looking for evidence that animals have been there. And we're evaluating the risk of contamination of produce. And the most important time to do this is immediately prior to harvest. So again, as close to harvest as possible, we should be doing what's called a pre-harvest inspection. We're going to walk through the crop. We're going to look for fecal contamination. We're going to look for other evidence that animals may be present, again, such as the chewing on those peppers. That's a very strong indication that mice are present in that particular area. And keep in mind, it's not just open fields that we're concerned about, because animals can also enter greenhouses and tunnels and other protected growing areas. And if we feel that animals have entered these areas, if we see evidence of animal intrusion, then we're going to assess risk and decide if the crop or a portion of the crop can be safely harvested. There have been situations where entire produce fields have been lost. For example, a group of feral hogs coming into a field and then rummaging around and dropping poop throughout the field can lead to the loss of the entire crop. More frequently, though, we're only looking at a small portion of the crop that may need to be discarded. But it's important to think through the process of understanding what the risk might be so that we don't accidentally harvest crop that has been contaminated. Let's start the discussion with domesticated animals. And again, frequently we have domesticated animals in close proximity to produce fields. And these domesticated animals can carry human pathogens. In some cases, we actually place domesticated animals in fields. Perhaps we have working animals. Perhaps we have dogs that chase wildlife out of fields. Perhaps we put domesticated animals in fields to graze crop residue or culls or to pull weeds or whatever it might be. But any time that we allow a domesticated animal into a field, we have to assess the risk. For example, using a horse in a field. Well, it's pretty clear what the risks are there, and we'll want to watch closely to make sure that horse doesn't defecate as it's working in the field. It can be trickier with animals like chickens and poultry and cats and dogs even. Frequently, it can be difficult to assess if those animals have pooped in the field. So again, assessing risks. Are these domesticated animals allowed into the field when the crop is present as we get close to harvest? Are they working animals or are they uninvited animals? And we also have to think about the people who are going to be harvesting these crops. Again, it's possible to carry cross-contamination on our bodies, particularly in our shoes and in our clothing and on our hands. And then we want to be cautious about equipment that we've used for handling animals or a fecal matter. The best way to minimize risk with working animals is not to allow them in the field as we get close to harvest. And in most cases, this is pretty easy to accommodate. We create a drive lane where the animal is kept, and we harvest crop by carrying it from the field to the drive lane. We do want to have a standard operating procedure in place that outlines what happens if an animal poops when it's near the field. For example, if we have a horse in a drive lane and it poops, we're not going to leave that poop there because it's likely that someone is going to step in it and then move into the produce field. So immediately after the poop is deposited, it needs to be removed and the area cleaned up. People who are working with animals should, again, understand the risks, particularly the risks of cross-contamination on clothing, hands, and shoes. Pets. We really need to exclude pets from produce fields. And I know this is a challenge. I've been on many farms where the dog and sometimes the cat are allowed free roam over the farm. And yes, there are some benefits, particularly with dogs, but it certainly carries risks if pets are allowed into produce fields. If you have visitors to the farm, they bring their pets with them, they should be instructed to leave their pets in their vehicles or at home. If you have a petting zoo, this certainly poses a significant risk, and it's important that petting zoos have hand washing sinks and also signage instructing visitors of your food safety policies. Okay, now let's talk about the pre-harvest assessment. And we'll talk about this in some detail. And basically, this is a process to understand if there is a significant risk from the standpoint of contamination at harvest. Okay, you're looking for fecal contamination, or you're looking for signs that animals have been there. Looking at this field of lettuce, we can see areas where feral hogs have come into that field and rooted up a significant part of the crop. This is a bad situation. It's likely, again, that there's been significant contamination in this field. Keep in mind the fresh produce that's been contaminated cannot be harvested. And corrective action, such as a no harvest buffer zone, is necessary. There are areas where we may see visible evidence of contamination, but there may be areas around the areas where we see visible contamination, where it's likely the contamination took place. So we'll talk more about that here in a moment. And then after all of this is done, harvest can then safely proceed. Okay, so what do we do if there's contamination? First of all, we don't harvest any produce that may be contaminated. We're certainly going to look for visible contamination. We're also going to assess the possibility of contamination that might not be so visible. What about this no harvest buffer zone? Well, here's a picture of contamination in a field. And if there's a reasonable certainty the contamination has been taken place, then we want to develop what's called a buffer zone that allows us to reduce that risk. Now, certainly where we visibly see the poop, this is obviously an area of contamination, but it's likely there may be some movement from that point to adjacent crop. Now, obviously, the characteristics of the poop or the manure need to be taken into account when establishing a no harvest zone, buffer zone. Something like deer poop, for example. Deer poop is dry. It's typically in a small pelleted form. It doesn't have a lot of collateral movement once it's been deposited. Contrast this with poop from a cow. Cow poop is loose. It drops from some height and splats after it lands. There's likely to be collateral movement of poop from a cow. So the no harvest buffer zone will be probably wider from the standpoint of cow poop versus deer poop. Now, what should that no harvest buffer zone be? The produce safety rule doesn't tell us what that should be. Farmers are encouraged to use common sense and the circumstances around a contamination event to come up with a no harvest buffer zone. But this buffer zone typically is between 0 to 25 feet. Some of the factors to take into account, first of all, the type of manure. Secondly, when did it occur? Has there been rain since? Has there been inadvertent movement of poop away from the area where it was first deposited? And how are we harvesting? Are we harvesting by hand where we can closely see any contaminated produce? Or are we mechanically harvesting where it may not be so evident? But again, coming up with that no harvest buffer zone is a combination of common sense and the characteristics of the particular event. In this setting here, we see poop. This was deposited by a bear. We're going to place a flag at the point where the poop was noticed. We're going to examine the area around it. This tends to be a type of poop that isn't widely distributed, and bears tend to deposit all of their poop in one location. So the no harvest buffer zone here would be certainly less than, say, if it were cow poop. What should it be? Well, if it hasn't rained since, then it might be reasonable to develop perhaps a 3 to 5 foot no harvest zone around this particular situation.
So Patrick, just real quick to interrupt you. So in a nutshell, you're saying whether there's species coming from pets, wild animals, what have you, like if it's within the vicinity of the of what you're hoping to harvest, you need to take a second guess and like protect a perimeter around the crops. Is that right? And then extra precautions if it has rained and then potentially spread the feces.
Yes, that's the case. Keep in mind that the feces or poop carries a significant risk of contamination. Almost universally, poop carries pathogens that make people sick. And also the produce safety rule tells us that we cannot harvest produce that is visibly contaminated with feces or poop. Now, it's all about risk management. And when we develop the size of a no harvest buffer zone, to some degree, it comes down to the farmer's willingness to accept risk. And my advice and the advice of produce safety specialists is that you want to err on the side of caution when it comes to visible evidence of poop in a produce field. That's just good risk management practice. Okay, so we've identified the situation. We've developed a no harvest buffer zone. Well, what should we do about it? There are several strategies. Perhaps the contamination, the poop should be removed. Perhaps it could be left. Perhaps it could be buried. In most situations, the poop is removed from the field. Let's think about cross-contamination risks. That we could pick that poop up on a shovel and walk out of the field, but what happens if we trip and the poop on our shovel is then spread over a wide area? Suddenly we've contaminated more produce. It's a much better practice to carry a bucket with us, pick up the poop, put it in the bucket, and carry it out of the field in the bucket. In some cases, it might be a reasonable decision to bury. For example, contamination from rabbits or from mice or some other animals that leave small, discrete, dry feces might be reasonable. In many cases, though, we're going to remove the contamination from the field. And then it's a good practice to document any situations that arise. Well, let's watch a couple of videos that give some guidance on the pre-harvest inspection and removing feces from the field. Okay, hold on just a moment here. Okay, at this point, Anna, can we see the blank screen?
Yes, we can.
Okay, let's start the video.
Hi, my name is Cal Jamerson. I'm the Produce Safety Associate with Kansas State University Research and Extension. Today we're going to be talking about scouting fields for wildlife and potential contaminants and the steps you should take as a grower in response. The first thing we're going to talk about is supplies. When you're scouting your field for feces or potential contaminants, the basics are a bucket for getting them out of the field, a shovel, and I also like the trowels for smaller contaminants. Also, you want to have flags, and we're going to go over this in greater detail after we scout the field and drop the flags. A note on color coordinating, you'll notice the bucket is black, the shovel is black with black tape on it, the trowel is black with black tape on it. You can pick any color you want. Red's pretty common when you're dealing with contaminants. The reason you want to have a dedicated color when dealing with this is so you don't have cross-contamination with your post-harvest harvesting equipment versus stuff you're getting contaminants and feces out of the field in. When you're doing field scouting, I would encourage using a two-flag system. The red being for when a feces or contaminant is present, and a yellow being if you see heavy signs of tracks, feeding, rooting, where there's not actually a contaminant, but you want your harvesters to be aware that there could be a potential contaminant nearby. In this walkthrough, I noticed bird feces on the plastic, not on the produce itself. So when I scout the field, I go through and drop all my flags, and then I come back for the removal cleanup. In this scenario, when it's not on the produce or the plant, what I do is I would use a wet one or Clorox wipe away from the plant, get it off the plastic, check the surrounding area, know what my weather's been the past few days, and then once that contaminant's been removed, I'm gonna switch to a yellow flag. The reason being is I still want my harvesters to know in this area there was a contaminant, to be extra cautious when they're harvesting. You do not have to do a 2-flag system. It's just something I encourage. Another example we gave in the previous recording is when there was feces outside of the bed, I dropped the red flag, then when we remove it, the weather was fine, there was no heavy rain, no heavy wind. So in that case, after I remove that feces from the field, I'm gonna switch to a yellow flag. So the harvesters know everything in there can still be harvested, just be extra cautious at that point.
I'm Patrick Byers, Horticulture Field Specialist with University of Missouri Extension. Well, we've identified evidence of animal egress in the produce field. What do we do now? Well, the first step, of course, is to do a good thorough walkthrough in advance of harvest and to mark any physical evidence of egress. It's also important to make sure that everyone who is going to be contacting produce, particularly during harvest, is trained on what to look for. The more eyes you have on the situation, the more effective will be your pre-harvest inspection. So once you've identified feces in the field, then it's important, obviously, to mark that with a distinctive flag, and then to determine what's called the buffer zone, and that's the area around the feces where there could be potential contamination. Now, what should that buffer zone be? Well, the guidance that we have is it could be anywhere from 0 to 25 feet, and that's quite a range. Some of the things to take into consideration, first of all, the characteristics of the feces themselves. Are they loose and watery? Is it likely that there was a splat factor? You know, could it have moved beyond where you physically see it? What has the weather been like? Has it rained since the feces were deposited? Is the wind blowing where there could have been wind-blown movement of the feces? These are all things to consider when determining what the buffer zone should be. Okay, can we see the second video now, Anna?
Yeah, it appears to be there.
Okay, if it doesn't come up and we have sound, go ahead and give me a cue.
We're gonna go to the actual removal process. This is where it's handy to have a good sized shovel and a little trowel. The feces here, you can tell it's fresh. It hasn't been stepped on. There's been no rain the last 2 days and the wind pattern's okay. So personally in this scenario, you can do a smaller buffer zone, and all you're gonna do is physically remove the feces from the field. Once you've done that, you're gonna put your flag back. Even though there's no fecal contamination, it's a good visual cue for harvesters to know that something did happen in this specific area. So when they're going about their day-to-day harvest, they know to be extra aware of their environment for feces.
While we tend to focus on feces from mammals when we do the field inspection, we also need to keep an eye out for bird feces. And as we can see here, we have an example of bird feces on the plastic. Pretty straightforward to clean that up. There's very little peripheral spread. So using an antiseptic wipe, we can just basically make sure that we remove the evidence of the feces and disinfect the area where it was deposited. Once you've done this, of course, this will need to be disposed of as contaminated material, and you want to immediately wash your hands with soap and single-use towels, and if necessary, use a hand sanitizer. Okay, I'm sorry about that. I got dropped.
Oh, you're good. We
Okay,
still
very
see you
good.
in the webinar, but you're not sharing your screen at the moment.
Okay,
you're
well,
all
let's
good.
go. Let's go ahead and get back to the presentation. Sorry about that, folks. Okay, are we back to the presentation, Anna?
Yep, I can see it.
Okay, very good. Well, again, these videos have been posted online. They're at the Kansas State University Produce Food Safety Toolbox site, and they're available if you'd like to see some, to go back and review these. There's other videos there as well related to produce food safety. Okay, now let's talk about some safe harvest practices, and this will wind up our time together tonight. And as mentioned earlier, if you have any questions, please enter them in the Q&A box at the bottom of your screen. Okay, so some thoughts on harvest containers. It's a frequent situation where crop is harvested into bins, buckets, lugs, or some other larger size container, and then transported back to the pack house, and then unloaded onto a grading or sorting table, or perhaps placed into a dunk tank. Well, it's important to think about those harvest totes and bins, and the produce safety rule requires us to keep those in a clean and sanitary condition. Now, how do we do that? Well, the first thing we want to do is to develop a standard operating procedure related to cleaning and sanitizing, related to the frequency at which we clean and sanitize. And many farms will clean and sanitize harvest containers at the end of each harvest day, so that they know the next time that they're going into harvest, those containers will be in a clean and sanitary condition. Now, how do you know if a container needs to be cleaned more frequently? Well, you look at it. Again, the produce safety rule doesn't tell us how frequently to clean and sanitize, but our common sense should. When we see visible evidence of soil or other contaminant in these containers, it's time to stop, clean, and sanitize. And remember that cleaning and sanitizing is a four-step process. First of all, we rinse the containers to remove visible debris. Then we scrub them down with soap or detergent and potable water. Then we rinse them, and then we sanitize them using a sanitizer that is approved for food contact surfaces. We should also be thinking about cross-contamination. Notice in this picture that the harvest container is actually sitting on the soil. And this is a situation where we can inadvertently contaminate the bottom of the container. And then when that container is placed in a wagon or a cart or some other transport, then it can contaminate the bed of the transport. If this container is then stacked inside of another container, the bottom of this container can contaminate the inside of the container in which it's nested. So if there's any way that we can reduce cross-contamination in the field, this can be helpful. Perhaps using platforms to set our harvest containers on, perhaps using a double layer harvest container where we leave the outer layer behind when we transport crop back to the pack house, perhaps using a stand, or perhaps using a mulch or some other barrier on the soil to help keep the bottom of these harvest containers clean. And then after we've cleaned and sanitized containers, it can be helpful to develop a way to stack these in such a way that buckets don't inadvertently contaminate the inside of the bucket or the container in which they're nesting. Harvest tool sanitation. Again, as we saw in the videos, it's a good practice to have dedicated harvest tools. This reduces the risk of cross-contamination. And all harvest tools should be cleaned and sanitized frequently, certainly on a daily basis and perhaps more frequently. This includes things like knives and pruners and hooks and other things that we're using to harvest crops. Transporting harvested crop. We want to make sure that the transport vehicle is clean and doesn't inadvertently cause cross-contamination of harvested product. Whenever possible, as we're transporting harvested produce from the field to the pack house, we want to cover it. And if we have to leave a load of produce in the open before it moves into the pack house, definitely cover it up. It's so easy for windblown contaminants to reach produce or for birds to fly over and leave feces behind on produce. So it's a very helpful risk management strategy to cover produce when it's being transported or if it has to wait before moving into the pack house. Worker hygiene. So harvest workers must maintain their hands in a clean and sanitary condition. Whenever contamination occurs, hands should be washed. And there are lots of ways that hands can become contaminated. Harvest workers should have access to potable water for hand washing. It's a very good practice to take a hand washing station to the harvest field with you on a wagon. That way, if you have to stop and deal with an animal, if you have to stop and deal with manure, if you have to stop and deal with some other situation where your hands have become contaminated, it's a simple matter to wash them. The produce safety rule requires that harvest workers have access to toilet facilities within a quarter mile or within 5 minutes of a harvest field. So keep that in mind as well. And if you're using gloves, those gloves must be changed or replaced when soiled. Disposable gloves, it's pretty straightforward to change to replace those. If using cloth gloves, then you need to have a standard operating procedure in place to guide when those gloves should be taken off and replaced with clean gloves. All workers who contact produce should be healthy and in good health. Workers should not be ill if they're harvesting produce. Now, what does this mean, workers who are ill? Well, any worker who is coughing, sneezing, running a temperature, or losing any sort of bodily fluid, for example, from a runny nose or perhaps from diarrhea, should not be harvesting produce. Now, granted, sometimes symptoms of allergies or other situations can mimic illness, but workers who are not ill must not handle produce. Dropped produce, produce that has fallen off of a plant and landed on the ground. In some cases, the produce safety rule does not allow the harvest and sale of produce that has fallen to the ground. So for example, if a tomato falls off the trellis plant and lands on the ground, the produce safety rule does not allow the harvest and sale of that tomato. The reason that this rule is in place is that if a produce falls to the ground, there is a strong likelihood that it's been bruised or damaged, and the contamination could actually be internalized in the produce. In this case, it's first of all difficult to understand that contamination has taken place, and secondly, it's impossible to clean that produce up. Now, there are some situations where we have produce that naturally grows on the ground, things such as melons. Well, these melons harvested from the ground are not considered to be dropped produce. And then we have some situations where produce is normally dropped before harvest. For example, nuts may be shaken off of a tree and then picked up off the ground, as we see in this picture here. Well, in this case, this crop is not considered to be dropped produce. Produce that is visibly contaminated with feces or other animal waste must not be harvested. This is just a guideline. It's a requirement of the produce safety rules. So produce that is visibly contaminated with feces or other animal waste must not be harvested. What about harvesting into sales containers? If we take harvested crop back to a pack house and we pour it out onto a grading or sorting table, it gives us a chance to look at that produce one more time with the eyes before it moves into a storage or a sales container. But in some cases, we harvest in the field into sales containers. This is an example here with these blueberries. Well, in this case, we're only going to use new clean containers. And all people harvesting have to be trained to watch out for contamination. It's also important, obviously, to watch out for cross-contamination because there's not another chance to examine these berries to sort out any contaminated berries. So it's very important to be very cautious when harvesting in the field into sales containers. What about pick your own harvest when we invite people to the farm to harvest crop? Now, the first thing to think about here, all visitors to the farm, including pick your own visitors, should be instructed to wash their hands before entering the produce field. It's also a good practice not to allow pets that arrive with pick your own customers into produce fields. From the standpoint of the harvest itself, the farmer should be providing the harvest container. It's not a good practice to allow customers to bring containers with them because in that case, you have no idea what happened to that harvest container before it arrived on the farm. It may have been used to transport something that resulted in contamination. So farmers should plan to supply harvest containers. And a good practice is what we see here on this blueberry farm, where the farmer provides a bucket with a plastic bag liner. The bucket is cleaned and sanitized on a daily basis. The liner is a new unused liner. It's placed in the bucket. The customer picks into the bucket when the bucket is full. It's returned to the sales area. The farmer pulls the bag out, puts a twist tie on it. And in this case, the crop is then in a situation where contamination is unlikely. So a good way to approach harvest on a pick your own farm. And this works equally well with crops like blackberries, strawberries, smaller vegetables. Well, that brings us to the conclusion of our prepared remarks. Some resources. I mentioned that there's information on cleaning and sanitizing, wildlife control, and produce safety and biological soil amendments on the Kansas State University Produce Food Safety Toolbox. So check those out. The web links are here on this particular page. And that brings me to the conclusion of the workshop this evening. Now, does anyone have any questions that we can address at this point?
Doesn't look like it right now.
Okay, well, this would be a good chance perhaps to take a screenshot or perhaps a picture of my contact information. I encourage you to reach out if you have any questions related to produce food safety, if you'd like to schedule an on-farm readiness review or anything else related to produce food safety. I'd love to visit with you about that. So I encourage you to make a contact. At this point, I think we're through with the workshop. Any final remarks, Anna?
You know, I think a lot of this, it's super helpful. A lot of it is just super straightforward, but seeing kind of the parameters around just where you draw the line before what's okay and what is not okay is really helpful. So yeah, I don't know. I think there's a lot of really good information, and I thank you for offering all of those resources where people can follow up about specific questions. And just again, I know people can reach out to you or me directly, and we can get them connected with people and experts who can really answer those properly. But thank you. I mean, all of it was very thorough and very straightforward, I think. So
well,
very good.
Produce food safety, first and foremost, is all about common sense. It's all about understanding the issues and developing strategies on your farm to address those issues. And as I said before, it can be helpful to have a specialist work with you. I'm happy to do that. There are others as well. So thank you very much for joining us tonight. And your presence here demonstrates that you understand that produce food safety is a very important thing to all of us. So I appreciate you being with us tonight.